All right, two more parameters may be needed whenever we are facing combination of two variables. We may need to find their covariance and the coefficient of correlation. Okay, so how to find the covariance? Here we go. We can use either this equation that says that we multiply each value of x by we multiply for every pair x and y the difference between the value of this x and its mean and the difference between this value of y and its mean, and we multiply by the probability of this specific pair of x and y. Okay, and or we can use this shortcut where it has two parts, and the first part is here where we multiply each value of x by the corresponding value of y given the probability of this joint, or the joint probability of x and y, meaning that this is the probability that this pair of x and y will occur. Then when we finish with these, all the x and y's, all the pairs, then we subtract the product of their averages. I'm going to use that in the next example. All right, then we're left with the coefficient of correlation, as also we learned previously that coefficient of correlation is the ratio of the covariance divided by the product of the standard deviations. Okay, we learn now how to find the covariance. We learned in the previous slide how to find the variance and thus their standard deviation. So this becomes very easy for us. Okay, so let's find the covariance of x and y given their bivariate probability distribution, and then we find their coefficient of correlation. So remember, the covariance can be found using this one. We have seen two methods to find the covariance, but I prefer this one given the bivariate probability distribution. It will be easy to use this. Okay, so first, how can I read this one? Okay, as I explained in the previous one, I want to multiply for every pair of y that I know the probability. I will multiply the value of x times the value of y. So in other words, look at the table here. So this the whole summation will be this. It's equal to 0 times 0 times 0.12 plus 0 times 1 times 0.42 plus 0 times 2 times this plus this times that, etc. Okay, so let me show you how I'm doing that. So I will show you one row at a time so that it will be easy for you to understand what are we doing. So here we go. I'm starting by multiplying the value of y by the three values of x. So here we have three combinations corresponding to y is 0. So for y is 0, I can have an x of 0, an x of 1, or an x of 2. So here we go for y of 0, 0, and 0. Okay, x can be either a 0 or a 1 or a 2. And these are the corresponding probabilities for the pair. So 0.12 is the probability that this pair happens. 0.42 is the probability that this pair happen, etc. Okay, so this is the first row. Second row will take care of the combination of y is 1 with all the other values of x. Okay, and you can see here that, for example, this 0.21, I'm getting it from here because I'm multiplying 1 times 0 times this. And the 0.06, it's 1 times their corresponding probability. Here we go, and so on. And the last row entails the value of y is 2. Okay, again, I have three possible combination corresponding to y is 2. Okay, so when I sum up all these, I get 0.2. So this is the first part. Here we go. This is 0.2. Don't forget to subtract the product of the averages. Okay, many students forget to finish their calculation with this last step, so don't do this mistake. Okay, so the covariance of x and y will be equal to 0.2 that we just got, minus we multiply the averages of x and y that we got in the previous calculations, and we end up with a covariance of minus 0.15. Okay, so it's a negative covariance, which is normal to find.